So much to do. It's like it's me against the world. What if I try to clone myself? Nah, can't be. What's this syringe for? I was just busy eating here when. Ah.
What JM is doing applies Boyle's law. Named after its author, Richard Boyle, Boyle's law explains the relationship of pressure and volume of a gas given constant temperature. Pressure and volume are indirectly proportional, meaning as pressure of a gas increases, its volume decreases, and vice versa. In the experiment, the air within the marshmallow compressed when the plunger of the syringe was pushed further into the body of the syringe, and pulling the plunger from its displaced position in the tube caused the air of the marshmallow to expand. A real-life example of Boyle's law is breathing, which involves inhaling and exhaling. When inhaling, the diaphragm constricts, meaning there is increase in pressure. It also decreases in volume. Upon exhaling, the diaphragm relaxes. Thus, the volume increases back to normal. To further understand Boyle's law, we would solve the following problem. What JM forcibly took from Eliza was a hair blower, needed to perform the demonstration he did. Such demonstration depicts Charles' law, which states that volume and temperature are directly proportional. As the temperature of a gas increases, so does the volume it has. This law also indirectly explains how a change in density may occur. Density, defined as compactness of particles of a gas, can be solved by dividing the mass of a gas by its volume. Based on the kinetic molecular theory, the average kinetic energy of a gas can be solely determined by its temperature. Both KMT and Charles' law would imply that increasing the temperature of a gas decreases its volume and density. Now, why were the paper clips needed? Well, because the hot air inside wanted to escape easily. It would have just flipped with the opening facing upward for the air to escape. The paper clips weighed down the paper bag in such way that it would not flip with its opening on the top. A real-life example of Charles' law being followed is a hot air balloon. The burner in the hot air balloon heats the gas, thus increasing the volume, which is visible by the increase in size of the air balloon itself. To further understand Charles' law, we would solve the following problem. Practice problem number 2. 250 ml was the initial volume at 20 degrees Celsius or 293 Kelvin, the initial temperature. 8 degrees Celsius or 281 Kelvin is the final temperature.
Aha!
What JM realized from the show was how Gay-Lussac's law is applicable to firing a gun. Gay-Lussac's law states that pressure and temperature are directly proportional, meaning that as pressure increases or decreases, so does its temperature and vice versa. Firing a gun requires burning of gunpowder that results to a superheated gas. Such heat has a high pressure that is responsible for the strong force of the bullet. To further understand Gay-Lussac's law, we would solve the following problem. Practice problem number 6. 400 Kelvin is the initial temperature and 0.55 atm is the initial pressure. The final temperature was 278 Kelvin.
What a dream. So weird.